Hello, everybody, and welcome to my talk about Azure App Gateways and Azure Front Door setups for using a reverse proxy setup on Azure App Service-based microservice deployments. For all of you who have bookmarked this video a couple of days ago, you might be surprised to see me here. The original session that was planned on this plot, on this track, had to be cancelled, sadly. And so I offered to substitute this topic on short notice for us now. So that's a talk I've never done before. I don't quite know how much content we really have, so it might be a bit shorter than the 15 minutes announced. But yeah, let's see how far we get on this point. My name is Raphael Schwarz. I'm a software architect and consultant and CEO of codeworx GmbH located in Wels, Upper Austria. And I do help and support a lot of customers in the DACH region, providing an architecture or designing solutions, cloud-based solutions for their company. And one of my customers approached me a couple of months ago with a very specific problem that he had, because he had to do a cloud-based reverse proxy setup for his web solution that contains 3 basic microservices: one identity service block, one backend service block, and a Angular-based web front-end microservice. And he had the challenge to set up those 3 microservices in a secure way in an Azure environment. And per policy, he had to use a application gateway in front of those microservices. And also, he wanted to use one single host name for all those 3 microservice applications. So he wanted to use, let's see, for our purposes, demo host, and then use the subsequent path segment that is there as a separator for the differently hosted microservices there. So I recreated this problem in a small example in Visual Studio. The examples are published on my GitHub page, so we will modify the code a little bit. So after this session, let's say 1-2 hours afterward, there will be the actual sample published at this very GitHub URL that you can see on screen right now. I will also be in the Discord channel afterwards, so if you have any questions, you can either ask it in the comment section of YouTube while the show is still live, or afterwards in our Discord channel. So first of all, what is Application Gateway and why would we want to use it? And let's see, there's a little, yeah. Basically, the Application Gateway is a small service that Azure provides that you can use as an intermediary between your clients and your actually hosted web applications. It is a web-based solution, kind of like a router, but for HTTPS requests and responses. And this intermediary has a couple of extra features that he can provide you to secure your applications or to help you scale your applications individually a bit better. In this scenario here, that is from the Microsoft documents page, you see in a very, very abstract way how this works. So you have your clients, you have your domain, and you have your application gateway that listens to this domain. And the application gateway itself is in a way a load balancer and is what's more important here, a web application firewall. So what does that mean? Web application firewalls are becoming more and more important in our web environment because of all the different attacks that are evolving and coming to life here. For example, if someone is trying to do a denial of service attack on your servers, you need some kind of protection against this kinds of attacks, and those kinds of attacks are often very hard, difficult to identify as an attack, because the line between just a lot of load on your system and a directed attack on your system that tries to bring your servers down is a very small one. So it's very hard to identify especially a traffic-based attack on as an attack and not just some load that you generate there. And so the web application firewall component of Application Gateway helps you to have those complex systems pre-serviced and pre-offered by Microsoft. And so you can basically, just by buying the service or activating the service, protect your actual backend microservices that you really want to protect here. Also, a load balancing feature, of course, is part of the application gateway here as well. We see here that there is we have our application gateway, and we have a set of backend pools here where we can, for example, use our deployed app services as part of such a backend pool and direct requests that arrive at the application gateway to those specific pools. And which pool to choose is decided by some kind of rudimentary rules engine or routing engine inside the application gateway. And so that is the application. Why should we use this application gateway? As I said before, one of the more important features here is that the application gateway provides us a pre-configured, predefined a web application firewall. And pre-configured means really there is a standard when it comes to web protection, intrusion detection, and those firewalls they comply to these standards and can help prevent some common attacks there. There is also a link from Microsoft. I will show you later where they specifically show you which of those setups you can use there and what it protects against. Another important part is that the web application file, the application gateway, can be your SSL and TLS termination point for your applications there. There is not really a need to use SSL or TLS connections inside your closed scope, inside your closed loop. So, for example, you deploy 3 microservices in a virtual network in Azure, and they communicate only internally, only inside this virtual network in Azure. Then there is no real need to use SSL and TLS for this communication in there. So you can use a secure channel from your client to your application gateway, but then use a non-secure HTTP request from the application gateway to the actual web server, to the actual microservice inside there. Why why do we care about using non-encrypted connections inside? I mean, it's a an interesting question. Mostly because every kind of encryption, SSL, handshake is a bit of overhead on the request and will slow down the overall performance of this web application. If it's not needed, you would not substitute performance now for security, but if it's not necessary, you can communicate internally without SSL TLS and use the application gateway as your termination point. Another point, and that is a thing or one of the reasons why my customer approached me back then was they wanted to use a single URI for multiple hosted microservices. So in this case, it was even a little bit more complicated because they wanted to use the root URI for the Angular-based application and just have some reserved first-level path segments there that point to the other microservices. So, for example, I have used the domain codeworx.eu for this sample here, and for example, the host should be demo.codeworx.eu, and then the first segment / identity should point to another microservice that is hosted in a separate app service, and yeah, provide the data from this specific microservice. Another important thing here is if you use a single host URI for multiple microservices for your setup, for your final setup, you can avoid CORS requests. If you use a different app services for your different microservices, each and every microservice at least has a different port number or host name. And if you cross the boundaries of your host segment in your browser, the browser does a CORS request just to ensure that you're really allowed to send requests to the specific domain from your web application. So if you host everything or if you present everything based on one host segment in your web application, the browser just simply doesn't care about CORS because it's not cross-origin. It is inside the same origin. And also, if we take a look at a microservice setup, we very often see that those microservices need to communicate internally. So maybe the identity service microservice needs to communicate with our backend to get some data from our database. Maybe the database microservice needs to validate tokens on the identity service, and so on and so on. And those kind of service calls that are not necessarily used from outside our deployment scope are not really necessary to expose to the public. So in that scenario, you could just simply define two different routes for your internal services. And the one route is just available inside your virtual network when they connect directly to each other. And the other route is just your public API surface that you expose through the application gateway to your web applications, to your apps, to your full clients, whatever you try to deploy. Also, hybrid scenarios are an interesting thing here. You could, for example, because app gateways are fully integrated in Azure Virtual Networks, you could, for example, use a VPN setup, a point-to-point VPN setup, and just use on-premise services also in this whole scope, and maybe expose even some on-premise hosted services through the application gateway and the firewall down to your on-premise service. Well, how does this work in the Azure scope here? If we take a specific look at the web application firewall of the application gateway here, you see there is a application gateway with a front-end component that has all the network layer configuration on it. So this application gateway gets the external IP address. It handles the domain, fully qualified domain name stuff, and just exposes your application to the public. Exposed to the public is everything through those listeners. So you can define a lot of different listeners, some HTTP, some HTTPS, and configure them. And that basically defines what the public can see of your services, of your service structure internally. And then it depends if you have the web application firewall activated or not. There is a whole lot of magic happening under the hoods there. That some engines inside the web application firewall analyzes the requests, analyzes the traffic history there, and decides if this request is valid or not. There are things like, for example, you can configure geographic blocking. You can configure some kind of recurring requests that you detect as an attack. You can configure things like it even goes as far as they take a look at the JSON and XML content that you provide or that you get from outside, and try to validate if there's some kind of cross-site scripting attack happening with your JSON response, for example. And so that is an optional feature. You can activate the web application firewall. You don't necessarily need to. If you don't activate the firewall, the listener directly passes the request through to the rules engine. And the rules engine is where the magic really happens. That is where the request is analyzed and is based on some key information, mostly the path of this request is decided to which backend pool this request is redirected or is forwarded in this case. Backend pools can consist on a lot of from a lot of different things. In this case, we have just 3 simple app services deployed in 3 separate backend pools. But could have a virtual machine in there. You could have even some external services that are used there. And also those services are monitored constantly. So you can configure a health check on those services. And so the rule engine, if you have a pool with, let's say, 3 differently hosted app services, let's say one is hosted in Azure, one is hosted in AWS, and one is hosted with Google. And the rules engine can do a health check on those services and decide if the Azure hosted identity service is not available. We redirect our request to the AWS region, or we redirect it to a different Azure service that is hosted in a different region here. So that's so far the theory part of it. So now let's take a look at the actual configuration and more importantly, the actual code that we have. This is a simple solution that's basically just a proof of concept that I made for them. And this is basically the solution with our 3 microservices. Those are just simple plain ASP.NET Core 5.0 applications. And this one is just a hosting application for the Angular application that is inside. Here is just an OAuth OpenID Connect based identity server, and that's just a very, very simple done ASP.NET Core API that just has a simple hello world service. So you have one controller, one root / hello, and yeah. But we are authenticated and authorized here. So this service is only callable if we get a token from this identity microservice and show it to our backend. Yep. So if I start this application locally, just a few seconds to build it, we should see that there are 3 Kestrel web servers starting in the background. Just a little more. Come on, can make it. Yeah. So you see the API is starting, the identity microservice is starting, and our view microservice is starting. And so if they are loading correctly, we should see shortly, yeah, they all started, and they all listen to different ports here. So the API service listens to HTTPS 5003, the view listens to 5001, and the identity listens to 5002. So if we take a look at the network traffic that we have here, we see that we load our service, we load our view application. So we load the Angular application here on port 5001. Then the Angular application gets its identity information from our identity service. And the identity service then gives some metadata, OpenID metadata back, and we can log in now. So so now we're back in our view microservice here, and now we can use the token and call our API microservice, and we are successfully authenticated, and we get back our data. So the request to our API and identity microservices. Here it is. You can see that there are actually 2 requests made here. First, the actual real request to the actual microservice, and the other one is this pre-flight request. That is a specific request that any browser now makes to check if this cross-origin request, because it's a different origin, different port number, different origin, is allowed or is not allowed. So in this setup, I just added a development course policy that just allows every origin, but only in development mode. So the service works very well locally. Then I took those services and deployed them, each service separately, to a new app service in my Azure environment. So, and those are the 3 services that I deployed here. So the only thing I had to do to make this service or those services run in Azure is just modify my configuration a little bit to get them to use the new URIs for the communication between the microservices. So in this case, I just configured in the Azure portal here that I wanted to use, instead of localhost port 5003, I wanted to use the URL of my hosted microservice in Azure. And so this works very well. So we can do the same thing that we did on premise here, and we can use this URL and see the same application. We get the same token. Yeah, it works, just runs in the cloud right now. So if we take a look at the HTTP request here, we still see the course request because, of course, it is a different URI that we are using here. It is demo view, demo-API, demo-identity, but it is running in Azure, and it works right now. But this setup currently is just exposing all of those three services in a non-secure way to the public, and so every kind of denial of service attack has nothing in front to prevent it from happening in this case. And also, I do have a TLS termination on every single microservice here, which is a kind of an overhead here. So we have to have three different SSL TLS handshakes to handle, and so on and so on. And also, I still do have these extra course requests in here that we might want to avoid here as well. So I first tried to go through the steps to create those application gateways live in this presentation, but it's just not possible to create an application gateway, a fully functional working application gateway in that short amount of time, because it just takes 15 minutes to deploy the thing here. But I will go through some of the setup steps here with you and show you what you can do there and what I did to get this specific application to work here. So you can create those application gateways just by giving it a name. See, for example. And then you can choose the tier that we would like to use here. And so for the thing that we needed to do here, it is very important to use a V2 version of the application gateway, because there's one little feature that the V1 version currently not supports, and I think there is no way to upgrade currently a V1 to V2. The difference between the WAF and the standard one is just the WAF, of course, has the web application firewall enabled by default. Might be a little bit more expensive, but yeah. You can upgrade the standard to WAF version afterwards. That is possible. And so if you create those networks, then you get to choose or create a new public IP address. So that's what we were talking before. That's the first stage of the application gateway, where the whole application gateway is exposed to the public through a public IP address that you then can choose to define in your, or to add a domain name to in your DNS service. And yeah, in this case, I already have a public IP address, and that's the one I used in the pre-configured application gateway. And that's basically what you do here. If you don't have the IP address already, you just give it a name, and it will create a new public IP address for you. The next thing is that you need to add your backend pools. In this case, I added a pool for every microservice I have. In this case, for example, identity. And then I would here continue to add pre-deployed app services to this specific pool. So that's the identity pool. So I choose the app service that is deployed for the identity microservice, and so on and so on. And so if you do this, there's a very big wizard that you can walk through there, and finally you complete everything. There's a short validation period, and then you can create the application gateway. That takes around 15 to 20 minutes to get this application gateway up and running. And what you're left with is this lovely configuration site here, where you can again configure all of your backend pools here, add new app services to this pool, and so on and so on. And so the initial wizard didn't really do the whole job for me. I had to add some additional configuration here. Most importantly, a custom health probe, because if anything other than some startup code between 200 and 399 is returned by default, it will not be probed correctly. So the backend pools by default all might have the state that they are not healthy, and so then the application gateway doesn't forward anything to a non-healthy backend pool. The rules that I defined there are pretty simple. It is basically just a rule that listens to our public IP address on the HTTP port. Nothing I would do in a production environment, but I just don't have a SSL certificate for this specific domain here. And then you can configure your rule, and those rules can be they have a root configuration here in this case, and there can be subsequent path-based rules that you can configure. And in this case, we say, well, every request that comes in here targets the view microservice with those specific HTTP settings. Those are just settings that tell them how to forward the data to the backend pools. And then we have two separate rules here when we say if something requests /API/ and then a wildcard. So every path that is beneath API will match this rule. Then it is forwarded to our backend pool API. If it's /identity, it's forwarded to backend pool identity. So well, that's a fine thing. So now I know with demo.codeworx.eu, I will hit the view microservice here. So the view microservice, if we take a look at the network, currently is configured to get the OpenID configuration from the identity server. But in this case, you see the OpenID configuration is still collected from the publicly hosted app service. That would not work if you put the app service in a VNet and only expose it through the application gateway. Just didn't have the time to do this here. So this request might work right now, but is not really what we wanted to demonstrate here. So we just need to reconfigure our view application to use the API URL, the new API URL instead of the current one. And so just let's do this configuration here. Yeah. So instead of this setup here, we just use the demo.codeworx.eu/identity. And instead of the service URL, we just use eu.api. Well, and then we do the same thing to our backend service, because the backend service also communicates with the identity service. So we do the same thing there. So that's the API. We do have a configuration here. So we can change the authority where he checks the identity values against perfectly. And we can remove the environment setting that I added here, development, because we don't need the course setup here anymore. And the application is currently configured that it's just enabling course requests if it is in development mode. So we can remove this one here, and we are in a full production environment here. Well, so far so good. Let's see how the request looks now. So demo codeworx.eu, and okay. So the application is now loading the information from, I don't know if you can see this one here, but it is loading from demo.codeworx.eu/identity, well-known OpenID configuration. But, and here's the thing we did not already handle. The validation says that the issue that is presented in the document does not match the expected issue. So in this case, here we see the old URL or the actually deployed URL of our microservice. And why is this URL now showing here? Because we changed the URL to our identity service here. Well, that's very simple because our OpenID Connect service works in a way that we expose a metadata document, and in this metadata document, you see what is the URL of the token issuer and what is the URL of our token endpoints and authorization endpoints. And this specific URL here is produced by the identity server when it starts up. It just takes whatever the system tells the identity server that the current host name of this application is. And so that is definitely a problem. So we need to address exactly that case. And that was one of the more difficult problems that my customer had, is to get our identity, our microservices to work with this new environment where we get the information that what is the original URL for this application through the application gateway. Because the application gateway basically just does the request instead of the actual client, so on behalf of the actual client. So it terminates the request at the application gateway and then does a separate HTTP request to the microservice in the backend. And so for the microservice, the actual client that requests the data is the application gateway. And so luckily there are some header informations that basically every reverse proxy, doesn't matter if it's application gateway, Nginx, or even the front door setup in Azure automatically adds to the request if it is passed through the reverse proxy stage. And that are the X-forwarded and X-original headers. And with the right combination of those headers, you can recreate the original URL, how it was requested originally. And so that can be on some places really, really important for us to get the information down to our application. Also, it should be in a way that our microservice doesn't need to be changed a whole lot to work with the application gateway as well. And so what I did here was I just introduced a new, there is, by the way, an already existing middleware that Microsoft provides that does exactly that thing with the forwarded headers. So if you do protocol bridging and port mappings and things like that, this middleware works perfectly fine. You can just use it, just enable it. If there is a forward header there, it just alters the request that gets passed to the next level of middleware there. And so that works, but not in our scenario, because our scenario is that the path is altered as well. So you get the demo.codeworx.eu/identity, and it is altered to just the plain server name on the actual microservice. So because parts of this uh, path segments are removed by the application gateway, that is an information we currently lose, and that is an information that is very vital in this case for the identity server, and might be for most of the applications. For example, if you have a raw MVC application, Razor application, or whatever in the background, all those little URL helper methods with the squiggly thing that identifies the base URL. All those extensions depend on the correct base path being set in the HTTP request. And that's a thing that the default middleware just doesn't do. And so in this case, I just wrote my own custom middleware. Use middleware. How should we call it? Let's call it Reverse Proxy middleware. Well, and I don't bore you with typing this little middleware here. I just walk you through the code a little bit. And so this middleware just gets appointed to the next level of our middleware stages here in ASP.NET Core. And we just take a look at the HTTP headers and react to the original X-forwarded and forwarded proto headers, and just rewrite the HTTP request that is passed through the middleware. So every stage after this middleware, and because it is registered as the first stage here, every subsequent middleware that is executed here will work based on the information that we set here on the request. So we just simply modify the request so that the application service no longer thinks the request is coming from the application gateway to the backend service. So we modify it so that the backend service knows exactly what the application gateway knows upfront. And as I said, those three headers are already handled by the Microsoft provided middleware for the forward headers. This one here is a little bit trickier because that is the one that is more or less custom. It is a de facto standard that the reverse proxies like Nginx, for example, use and that they provide, but it is just simply not implemented in default here. And so this one here just enables us to pass an additional header with the pass information, and that simulates the microservice that we would have made a request actually on demo.codeworx.eu/identity. And so every URL that is generated from the backend now thinks that that is the actual URL the web application is hosted under. And so with this little bit of customization here, we can just push the publish the service to our cloud. And so if it's published, we should see the original URL here at demo codeworx EU. That went a lot quicker when I tried it 2 hours ago. Yeah. Well, so now we have the new version deployed, and you see the issuer here is altered, and he now knows that the issuer actually should be demo.codeworx.eu, and the URL should be demo.codeworx.eu.openid10. But we're still missing the /identity portion here. And that's where the v2 feature of our application gateway comes into play. And that is that the v2 version here has one additional entry here, and that's rewrites. And so you can not just define rules to redirect your requests to different backend pools, but you can also modify the requests here with this rule engine. And in this case, we have just the headers, let's call it, rule engine, and we use the identity target here as a target for this rewrite rule. You can use conditions here, but in this case, we just want to add to every request that passes through this rule path a new custom header, and this custom header is x forwarded dash path base. And the value for this one should be /identity. So that's how we tell the backend service that we actually want to host or present the web application with this base path set. And that is a very minor addition that we had to make to our microservice here that works in basically all of the cases I've tested so far. If you just add this little information here in the middleware, then the doesn't seem to work. Knowing me, it must be something very close to a typo. X forward, yeah, of course, it was a little typo. And so now the microservice in the background knows about the extra path segment here. And now we can use this application to actually log in within one base URL that is demo.codeworx.eu and use all the three services through this one base URL, demo.codeworx.eu. demo.codeworx.eu/identity, and if we call it, the hello service is exposed through demo.codeworx.eu API hello. So that was a setup that was done in App Gateway, and the reason was that the customer actually already used application gateways, and so that's why we used the proof of concept here in the application gateways. I also tried to replicate the same thing in front doors, and it is basically working more or less in exactly the same way. Except the wizard, I think, is a little bit more intuitive in front doors. It has basically these same sets of features for what I wanted to do. So there's also a web application firewall you can activate. You have a routes engine where you can define your path segments that should be used for the routing. So you have this nice designer here, and yeah, and so on and so on. The thing that really made the difference for me here was that the front door designer is able to use HTTPS without requiring you to upload your own custom SSL certificate here, because Microsoft can handle the SSL certificate for this domain here. All you need to do is add a CNAME entry to your domain name here, and if you enable the certificate management front door managed here, then Microsoft is providing the certificate, maintaining the certificate, and you don't have to worry about anything in here. And so I deployed this one here in demo 2, and this one here is actually deployed as HTTPS because it didn't require me to buy a new certificate. And that was demo 2 EU, and same thing, just exposed through the web application through the front door configuration instead of the application gateway thing here. So for my scenario, for this specific scenario, it worked quite similarly, and it looked as if you could substitute front door here for app services. But well, that seems to be it for now. So well, I will be around in my Discord channel afterwards. Here again, the GitHub URL for my samples. So all the code I showed you here is available at this GitHub repository. Have a look at it. Visit our website at codeworx.at. And well, I think we are 1 minute past our actual target, which is for me quite impressive. And yeah, well, then I would say thank you to all of you for watching, and I'll be around in the Discord channel if you need some extra information.